Recall that a function is a rule which provides exactly one output for each input. So f of x equals 2x plus 10 is an example of a function. And in this function, f of 3 is equal to 16. It just didn't show all the work of 2 times 3 plus 10, but that should be 16. We say f of 3 is 16, so be sure to say that word of. F of 4 is equal to 18. To try to introduce the words input and output into this, when the input is 4, the output is 18. F of 5 is equal to 20. When the input is 5, the output is 20. This slide only shows one function. We just saw what output you get when using input 3, and when using input 4, and when using input 5. Now consider the function f of x equals 8 over x minus 3. Is there any input x for which f of x would not be defined? Now, there would be a problem if we divide by 0. So how would we end up dividing by 0? We have to make sure, by the way, that the denominator x minus 3 should not be 0. So we need to avoid when x minus 3 is equal to 0. So we set up this equation and then talk about how to avoid this. If we add 3 to both sides, x equals 3. So there would be a problem if x equals 3. Basically, x equals 3 causes a problem, and other values of x do not cause a problem. Yeah, okay, so the conclusion here is the input x equals 3 would lead to f of x being undefined. Or a shorter way to say this is just f of 3 is undefined. As a follow-up, using the same function, f of x equals 8 over x minus 3, let's find f of 7. Now this should be fine because 3 is the only input that would be a problem. So using 7 as an input shouldn't be a problem. F of 7 is equal to, plugging in 7 for every x. So f of 7 equals 8 over 7 minus 3, in other words, 8 over 4, in other words, the number 2. Now, as a follow-up, using the same function, okay, still f of x equals 8 over x minus 3. Let's find f of 1. 1 isn't a problem either because, 1 isn't 3. I mean, 3 we saw would be the only input that would cause a problem. 3 would be the only value of x which would cause the denominator to be 0. So let's see what happens when we plug in x equals 1. So we have f of 1 equals 8 over 1 minus 3, in other words, 8 over negative 2, and we'll get negative 4. Okay, so those work fine. We can find f of 7, we can find f of 1. We can't find f of 3, that's the only problem. So in this example, x equals 3 is the only problem. X greater than 3 is not a problem, and x less than 3 is not a problem either. Okay, recall that a function is a rule which provides exactly one output to each input. Now here's another function. F of x equals x squared plus 1. That's an example of a function. F of 5 equals 26. When the input is 5, 26 is the only output. Now I'm trying to focus on this exactly one output business. 26 is the only output when you think of input 5. F of 6 equals 37. When 6 is the input, 37 is the only output. F of negative 6 is equal to 37 as well. When negative 6 is input, 37 is the only output. Now, each input leads to only one output. However, a certain number may appear as the output to more than one input, which we just saw here. For example, in this function, the number 37 is the output for two different inputs, namely the input 6 and the input negative 6. We skipped showing all the work. So for example, f of 5, if we did show some work, it'd be 5 squared plus 1, which would be 25 plus 1, which would be 26. I thought, actually, on this slide, towards the top, showing all that work would kind of get in the way of the big argument here. So we just summarize this as f of 5 is equal to 26. Always feel free to show the work, but here I wanted to really emphasize just talking about 5 and 26 and how they're related to each other here. So when the input is 5, the output and the only output is 26. Okay, let's look at this function. If g of x is equal to 2 to the x plus 10x, find g of 1 and g of 3 and g of c. So in this function that's been provided, I think we should notice that x appears once before the equal sign and twice after the equal sign. So how do we find g of 1? We should write what was given to us, g of x equals 2 to the x plus 10x, with this following exception. We just need to replace every x with a 1 instead. So g of 1 is equal to 2 to the 1 plus 10 times 1. That can simplify further, but we're not going to right now. How do we find g of 3? Take g of x equals 2 to the x plus 10 times x and replace every x with a 3. So g of 3 is equal to 2 to 3 plus 10 times 3. Again, that can simplify further, but we're not going to because it'll be much easier to draw parallels. How do we find g of c? We were not given a number for c, but in the same way as we just found g of 1 and g of 3, we should write g of x is equal to 2 to the x plus 10 times x, but replace each x with a c. So g of c is equal to 2 to the c plus 10 times c. So apologies for not really simplifying g of 1 and g of 3 any further, but by not simplifying, I hope it's a little clearer what's going on in trying to find g of c. So given the function f of x equals x squared, let's do 4 things. Find f of 10, find f of s, find f of 10 plus s, and then find f of 10 plus f of s. So the notation will guide us each time through. So finding f of 10, well, that's more the warm-up here. F of 10 is 10 squared, which simplifies to 100. To find f of s, that's s squared with no further simplifying possible. To find f of 10 plus s, replace every x up there in red with 10 plus s instead. So f of 10 plus s is 10 plus s quantity squared. Just keep in mind that this exponent does not distribute, so this won't become 100 plus s squared. And then for the last part, to find f of 10 plus f of s, I think sometimes people overthink this, but the thing is the plus sign is located in a great location that we get to split this up into 2 separate problems in our minds. So we've got the f of 10 part highlighted in yellow, and we have the f of s part highlighted in blue. So f of 10 becomes 10 squared in yellow, and f of s in blue becomes s squared, highlighted in blue. And we could certainly rewrite part D as 100 plus s squared if we want. But the key thing is that the final answer to C and D look different. So here are some common warnings, right? So if you did want to write 10 plus s quantity squared out, it'd be 10 plus s times 10 plus s. And when you FOIL this out, it'll be 100 plus 20s plus s squared. So be careful not to distribute the exponent. And I think the other key thing to note here is the final answers to part C and part D are different. So f of 10 plus s is different from f of 10 plus f of s. And in general, f of a plus b is not the same as f of a plus f of b. OK, so here are the computations that we had just looked at. The key thing to point out really is that given a function like f of x equals x squared, these 3 computations above are going to be all different. So f of 10 then plus an s is different from f of 10 plus s, which is different from f of 10 followed by a plus f of s. All 3 of these are different. And in general, given a function, the values of f of 10 then plus an s, or using the input 10 plus s in the function f, or computing f of 10 and f of s separately and adding the results, those are all different from each other. The most challenging of these 3 seems to be finding the middle one, finding f of 10 plus s for people. But as long as you remain consistent and plug in as appropriate, things will be fine, right? To just a common reminder of how to think about finding the output for a function is given f of x equals x squared, to find f of 10 plus s, you should write f of x equals x squared, but replace every x that you see with a 10 plus s instead. So f of 10 plus s is 10 plus s quantity squared. OK, so please be consistent no matter how many times x appears, right? So this is a fairly typical situation. If f of x equals 10x plus 7, find f of 2. There's an x on the left, there's an x on the right. But all the x's are going to get replaced with 2's. So f of 2 is 10 times 2 plus 7. We could simplify this to 27, of course. And then if g of x is equal to 10x plus 7x cubed, find g of 2. Well, now there's 1x on the left and 2x's on the right, but replace all the x's with 2's. So g of 2 is 10 times 2 plus 7 times 2 cubed. And we could simplify that to 76 if we'd like. And then how about h of x is equal to 10? Notice that there's an x on the left and there is no x on the right. But we should just replace every x we encounter with a 2. And there's only one x. It's the one on the left of the equal sign. So h of 2 is equal to 10. Sometimes people accidentally think that h of 2 is equal to 2. But just be very consistent. No matter what, no matter how many times x appears, all we're doing is replacing every x that we encounter with a 2. Nothing else gets replaced with a 2. So just to comment on this, f had 1 x after the equal sign, g had 2 x's after the equal sign, h had no x's after the equal sign, and in all the examples, all we did was replace every x with a 2, and nothing else got replaced with a 2. Sometimes people want to accidentally put a 2 here when there should just be a 10. Yeah, nothing else was replaced with a 2. Common error to say that h of 2 is equal to 2.